Hey guys, for trigonometry, this is from 7.3, and for pre-cal, this is from 6.3, and this section is called polar coordinates. So we're used to graphing on a rectangular graph with x and y, where x would move us left and right, and y would move us up and down. I want you to take a moment and think of any movie that you've ever seen that has maybe like a submarine or a plane, and their navigation system usually looks circular. Maybe if you own a boat, or your family does go out on a boat, you'll see your GPS even looks like this. So whenever we're working with polar coordinates, instead of x comma y, we have an r comma theta. I want you to look at the theta first. It's going to work just like your unit circle, which is what I drew here. And if I give you a positive theta, just like your unit circle, you're going to go counterclockwise. And if I give you a negative theta, you're going to go clockwise. Okay? So now, afterwards, once you spot your theta, you're going to find your r. R is going to be the distance out, meaning these rings. So notice I put a 1, 2, and 3 here. You can place as many rings as you need to, or you can even count this as 2, 4, 6. Okay? So let's say our theta that was given was pi over 2. Okay? And then I gave you a 3 for your r. You would look at your theta first of pi over 2. And then your r, if it's positive 2, would go towards the pi over 2. And I'd land right here in the second ring towards pi over 2. If I would give you a negative 2 comma pi over 2, negative means you go away from theta. So instead of going towards pi over 2, negative 2 would mean to go 2 rings away from pi over 2, which actually has me going towards 3 pi over 2. Okay? So let's take a moment. I apologize for my drawing. I'm sure you can find these on Google and print them out, and it's a lot easier. Let's plot these, okay? So the first one says 4 comma 30 degrees. Well, I know that 30 degrees is the same as pi over 6. And then I'm going to go 4 rings out towards 30 degrees. Now, I only drew 3, so I'm going to pretend there would have been a 4th ring over here, and I'm going to put a little dot. And this is going to be my A. Okay. B says 3 comma 3 pi over 4. So I'm going to look for 3 pi over 4, which is right here. Okay, this line. And I always start from the origin. So from the origin, looking at 3 pi over 4, I'm going to go 3 rings towards it. 1, 2, and 3. Okay, this is my B. So those both gave me positives. Let's start looking at if I have one of them negative. Okay. This says 120 degrees. It's the theta I'm going to look at. And then I'm going to go backwards away from 120 degrees towards 2. So we know that 120 degrees is the same as this 2 pi over 3. If you don't remember that, you can use conversions, which is on an earlier video, or you can just take out a unit circle, okay? So this is 120 degrees, this first tally in this second quadrant. Instead of going towards it, I'm going to go away from it, which would land me 1, 2 over here. And that's C. And then the last one we're going to look at has both of them being negative. So I'm going to go to negative pi over 4. If pi over 4 is 2 sticks upward, negative pi over 4 is 2 sticks downward. Okay? So initially, if I'm in the origin, I'm looking, this is the same as negative pi over 4. So I'm looking at this tally, this stick here, but then instead of going 1 towards it, it wants me to go 1 away from it, which lands me over here, and that one is D. Okay? All right, so now that we know what it looks like to see that on a graph, I'm going to show you how to convert back and forth between the two. Okay, so let's say a GPS system on your phone, you can use it while in your car, and that's more of an XY coordinate because on our streets we can only go left, right, forward, or backwards. But let's say we create a GPS system that lets us convert over to polar, so now we can take it on our boat and use it in any direction that we need to. Okay, so we're going to go first from polar to rectangular. Okay, that means we're going to go from r comma theta to x comma y. So if we are given r and theta, we're going to plug them in on this right side, and that's going to give us what x and y are. Now, for those of you in my pre-calc class that I have you memorized, this should make sense because on my unit circle, cosine is your x and sine is your y. So that relationship there should make sense. And then if I'm going from rectangular to polar, it means I'm going from x comma y. That's what be given. And I'm finding r comma theta. So I would plug my x's and my y's in this right side, and that would give me r and theta. Which this top formula here should remind you of Pythagorean. It's like a squared plus b squared equals c squared if the square root was on the other side as a squared. And then the fact that tangent in my unit circle is sine over cosine should make sense that this says y over x. Now, a big advantage that you can use is to plot this first and then convert, because when you plot, it's going to tell you what quadrant you are in to at least give you that idea of what numbers to be looking for. So let's check this one out. Okay, I know that if I'm plotting, pi over 2 is on the top. Okay, here's my pi over 2. And then if I had 3 rings, I would go 3 rings up towards pi over 2. So let's say that was my 3rd ring. And then I had a 2nd one and a 1st one. Don't mind my drawing. But at least I know that this is supposed to land up top on the y-axis. Okay? So now, let's find what my x and my y are and see if this makes sense. So x is r, which is 3, times cosine of pi over 2. Okay? Now, cosine of pi over 2 is 0, so I have 3 times 0, which just gives me 0. Okay? Now, y is going to be 3, the r, times sine of pi over 2. Okay? So sine of pi over 2 is 1. So that's going to leave me with 3 times 1, which just gives me 3. So my x comma y here is 0 comma 3, which if I look at the image that I had drawn, the fact that if, let's say I'd put an XY grid right on top of this, the fact that I didn't move on my x's and I went 3 up, that should match up with what you drew. So let's take a look at this next one. I would suggest that you pause the video, try and do it on your own, and then watch me solve it. If I'm going to graph this, 2 pi over 3 is in my 2nd quadrant. Okay? Now, negative 2 means that I'd go away from 2 pi over 3. So, if 2 pi over 3 is here, but I'm going to travel away from it, it means my point is going to land somewhere in quadrant 4. All right? So let's see if I get an ordered pair that matches up with me being in quadrant 4. X is r, which is negative 2, times cosine of 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2. And if you're wondering how I'm doing that so fast, I usually have my pre-calc students traumatized having memorized that unit circle. But if not, you can have a unit circle right next to you. So when you multiply 2 times negative 1/2, that gives me 1. And now let's do the same thing for y, which is my r, negative 2 times sine of 2 pi over 3. And that gives me radical 3 over 2. So 2 times radical 3 over 2. Those 2's are going to cancel, and I'm just going to be left with negative radical 3. All right, so my x and y here is 1 comma negative radical 3. Which, if I have a positive x, it means I move to the right. And if I have a negative y, it means I move down, which should match up perfectly with what I assumed with my drawing here, my little sketch. All right, we have our next question here. We're going to convert the other way around, rectangular to polar. So if I give you x comma y and I want r comma theta. So first thing I'm going to do is I'm going to plot this. Maybe I don't know what radical 3 is. I definitely know radical 4 is 2, so this is going to be a number a little smaller than 2. So let's say I go almost to 2 on my x, and then I go down to negative 1. This lets me know that I'm going to be in quadrant 4. Okay? Now, if I have x and y, I need to find r and theta. R is found by doing the square root of x squared plus y squared. And make sure you're very careful with your parentheses here, because when you square negative 1, that negative will disappear. So I have the square root of 3 plus 1, which is the square root of 4, which just gives me 2. There's my r. And now theta is found by doing inverse tangent of my y, negative 1, over my x, radical 3. Okay? So in 4.7 for pre-cal and 5.7 for trig, we went over inverse functions and how to find inverse tangents. So I know I need a value of tangent in the fourth quadrant. So you should be asking yourself, when does tangent equal negative 1 over radical 3? Okay? And again, hopefully if you remember those inverses, you can remember 11 pi over 6. In inverses, it might have given you negative pi over 6. So let's say if you do inverse, you get negative pi over 6. Okay? But negative pi over 6 is me talking about going backwards. If I want to use a proper theta, what I'm going to do to that is I'm going to add 360 or analyze through my unit circle, or excuse me, instead of 360, add 2 pi. Analyze with my unit circle which pi over 6 lands in quadrant 4, and that is 11 pi over 6. Okay? And if you would have added your 2 pi, you would have gotten to 11 pi over 6. All right? So that means that my r comma theta should give me 2 comma 11 pi over 6. And again, we can compare that to the sketch we had drawn. If I would be looking at that theta, 11 pi over 6, it would land me in quadrant 4, and then I'd go 2 rings out. So it matches up.